All right, we are moving on to lesson 8. Lesson 8 is the start, basically part 1 of a part 1 of a 2-part lesson on dilations. Remember, dilations have to do with changing in size, either making things bigger or smaller. The way that we're going to describe dilations are stretching and squashing. So today we're going to talk about, in part 1, in lesson 8, we're going to talk about vertical stretching and squashing. And in lesson 9, in the next lesson, we'll talk about horizontal ones. But anyway, so when we talk about vertical stretching and squashing, I literally mean taking a graph and stretching it vertically, or squashing it, squishing it, would be a better way of putting it, vertically. The way I like to think of it is, imagine stretching a graph like you would open up an accordion. A squash would be like closing the accordion vertically. And if you remember, it turns out our rules in terms of function notation are very similar to what they were with vertical shifts. Remember, with vertical shifts, way back in lesson 2, I believe, we didn't do the opposite. Okay, so if we were doing a vertical shift up or down, we would actually do the plus or the minus, and that number would go outside. And the same thing is going to happen here. So for a vertical stretch, all our outputs, all our y values are multiplied by a constant. Okay, that goes outside the parentheses. Okay, it goes outside the parentheses. And there's no opposites. So if the number you're multiplying by is greater than 1, that means you're making it bigger. We consider that a vertical stretch. If the number that you're multiplying by is less than 1, okay, think about it. If the number is less than 1, that would be a decimal. That means you're making it smaller. So that would be a vertical squash. All right, and that number C is known as the factor. Okay, so with that in mind, let's go ahead and take a look at the first part of the examples here. So examples: determine how to modify the red graph f of x to get the green graph g of x, then write the function notation. Okay, so we want to go from red to green. So notice, let's take a look at our points here. Okay, so we want to take a look at a couple of points on the graph. So notice this is going to be a vertical stretch or squash. Now, in this case, red to green, vertically, it looks like we go from 2, 4, 6, 8. Looks like we go from 8 to 2. Okay, looks like we go vertically from 8 to 2. If we actually look at the y-axis here, and just look at the y value, since we're just focusing on vertical stretches and squashes today. So we're going from 8 down to 2. 8 down to 2. So it's going down, it's getting smaller. So this is a vertical squash. This is a vertical squash. And with vertical stretching and squashing, we don't do the opposites. So to go from 8 to 2 would be to divide by 4. Now remember, dividing by 4 is the same as multiplying by 1/4. So we would say that the factor is 1/4. So the vertical squash, it's a vertical squash in which the factor is 1/4. So to write the function notation, Okay, we're going to do just like we did with um, with shifts. So we're going to write f of x equals g of x. Because it's vertical, we're going to put it outside, and we're not going to do the opposites. So we're not going to do the opposites. So we're just going to write times 1/4. So f of x equals g of x times 1/4. And that is all we're going to do. Okay. Let's do the second one, the one in the middle. Okay. If I look at the graph here, it looks like this one, we're going red to green. This one is 25, and this one is 5. So we're going 25 vertically down to 5. 25 vertically down to 5. Okay. So that is going to be a vertical squash again, because it's getting smaller. And the factor 25 to 5 is dividing by 5. So my factor is going to be 1/5. Okay. Another way you can get the factor is doing doing the ending number divided by the starting number. So the ending number is 5. The starting number is 25. 5 divided by 25 is the same as 1/5. 5 over 25 is the same as 1/5, just like 2 over 8 is the same as 1/4. So this is a vertical squash. The factor is 1/5, so it's going to be literally the same thing we did in the first one. This is going to be f of x equals g of x times 1/5. Right? Let's see. Let's do the third one. So we are going red to green, so we're going from 1 to 3. We're going from 1 up to 3. 1 up to 3. Red to green. So this is clearly a vertical stretch because it's getting bigger. And the factor to go from 1 to 3 is to multiply by 3. So the factor is 3. The factor is 3. And again, if we did the ending number divided by the starting number, the ending number in this case is 3. The starting number is 1. 3 divided by 1 is 3. So my function notation is going to be f of x equals g of x times 3. Okay. And that is it for the first part of our examples here. Let's go ahead and look at the second part of the examples. Okay. So, the Hulme Arch Bridge in Manchester, England is shaped like a parabola. The ends of the arch are 52 meters apart, and it is 25 meters high. Juan wants to model the shape of the arch with a graph of a function, and he chooses h of x equals x times 52 minus x, where h of x is the height in meters above a point x meters along the base of the arch from the left end. Part 1, number 1, label the 3 points on the graph. So this point right here, the x value is going to be 0, and the y value is going to be 0. Okay. Let's do this point on the end here. This point, x value is still 0. The y value is still going to be 0, right? Because there's no height. But they said it was 52 meters apart. So this is 52, 0 because of this right here. Okay. And then this one is in the middle. So if our x values go from 0 to 52, The middle would be 26. Okay. And this would be the high point of the arch. And what did it say that the height was? The height was 25 meters. So 26, comma 25. So that's number one. Graph h of x on Desmos. Compare the height of h of x with the height of the actual arch. So that's this one right here. Okay. So we know that the height of the arch is 25 meters. Okay. The height of each of x we have to use Desmos for. So let's go to Desmos. Let's pull up Desmos on our computer. And again, that function is x times 52 minus x. Okay. So we're looking, this is an arch, so we're looking for the high point of the arch. Obviously, we have to scroll up a lot. You can see the height is going to be a lot higher than 25 meters. Notice the height in this case is 676 meters if we actually look at the high point on the graph. So the number two, the height of h of x is 676 meters. Okay. So graph h of x on Desmos, compare the height of h of x with the height of the actual arch. This right here is your answer to number two. Okay. The height of each of the graph is 676, but the height of the actual arch is 25 meters. Which transformation would need to be done to h of x in order for it to fit the actual arch? So if we go back and look at the graph of h of x, notice these 2 points are correct. And this point, notice the x value is correct, but the y value is different. So in order to get it so that these 2 points stay the same, okay, I could not do a shift, because if I shift this down, then these points would move with it. So the only way that I can move this point down while keeping these points where they are is to actually do a vertical squash. Okay? I have to do a vertical squash. Okay? So this would be, which transformation would need to be done in order to h of x in order for it to fit the actual arch? It would be a vertical squash, because I would have to move it down. I would have to decrease the height of the graph in order to get it to fit the arch. So that would be a squash. And by how much meaning what would the factor be? So the factor in this case, my ending number, is 25, because that's where I want the height to be. And my starting number is 676. So I'm going to do my ending number divided by my starting number. Ending number divided by starting number. So my factor in this case would be 25 over 676. 25 over 676. So that would be 25 over 676. And because it's not a good looking decimal, we'll just leave it as a fraction. Again, I get the factor by doing ending number divided by starting number, not the other way around. Not the other way around. So ending number divided by starting number. So I wanted the graph to be at 25 meters, but it started at 676 meters, so 25 divided by 676. So to answer number 3, which transformation would need to be done to h of x in order to fit it to the actual arch? That transformation would be a vertical squash. And by how much? That how much would be a factor of 25 over 676. And that is it for lesson 8.